Hello and welcome to Success Spectrum Academy. I'm Krishna Mohan, and in today's session we'll exploring the fascinating chapter 1 of ICSE Class 10 Physics, that is force. Have you ever wondered why doors are easier to open when you push at the edge, or we can say end of the door, right? Yes, no, or we can say end point of the door, or how the tightrope walker managed to stay balanced. Okay, so these everyday phenomena are beautifully explained by the concept of turning force, okay, moment of force, or force in equilibrium. We'll also uncover the mystery behind why objects stay stable by learning about the center of gravity and see how these ideas connect to the concept of uniform circular motion. Okay, so we'll see about motion of planet, wheels, and even athletes, right? It's no in a racetrack. So I'm going to means completely follow the ICSE syllabus. This video is going to exam oriented only. I'll be focused on the questions whatever they asked in the previous year. Okay, that previous year question will be means followed in this session, and using simple example and practical numerical problem, I'm going to means I'll break down the concept to ensure okay they are crystal clear to everyone. Okay, so grab your notebook and let's dive into the world of force and motion. Okay, so if I'll ask what is force, right? Yes, no, so everyone will say, sir, it is push and pull, right? So yeah, that is also correct, but force is rate of change of linear momentum, right? Yes, no, so what is force? So force is rate of change of linear momentum. So here I can say this, okay? So if we'll define the force, so force is rate of change of linear momentum. So what is linear momentum then? So momentum is mass into velocity, right? Yes, no, so here I can say this rate of change of linear momentum is called force. So mass into velocity is known as P, that is linear momentum here, right? Yes or no? So here I can say this mass, it is a constant, okay, and we have velocity upon time, right? Yes, no. So change in velocity with respect to time is known as acceleration, right? Yes, no. So here I can say this dv upon dt, okay. So this will be change in velocity with respect to time is called acceleration. So force when applied on a rigid body. So if you are going to apply a force on rigid body, okay, it causes means here I can say this motion in it, right? Yes, no. So here I can see okay, it causes motion in it, right? Or when it is applied on non-rigid body, can cause both change in shape or size and the motion in it, right? Yes, no. So here I can say this if we are applying force, this is suppose we can consider a body we have, okay, so it will create the motion in it. And here if we are applying the force in a non-rigid, this was a rigid body, right? Yes, no. So here I can say that this is a rigid body we have, and here we have non-rigid body. So non-rigid body like means we can say clay, or we can say a dough, right? Yes, no. So in that shape is going to change. So here it is non-rigid body and can create motion as well. So what is the SI unit of force? So SI unit of force, we know that Newton, right? Yes or no? So here I can say this mass into acceleration. So mass we can define in kg, right? Yes, no. Acceleration will be meter per second square. So kilogram meter per second square is nothing, that is Newton, right? Yes, no. So here it is a Newton. Then we can define it as kilogram force as well, right? Yes, no. So kilogram force, so 1 kilogram force equal to what? 9.8 Newton. So 1 kilogram force is 9.8 Newton, we can say. So what force will do? So force causes change in state of body or change in shape or size of body, right? Yes, no. So change in state of body or change in shape or size of a body, right? Yes, no. So here I can say this, the first part we are going to start here, that is moment of force and equilibrium, right? Yes, no. That first section here, that is moment of force and equilibrium. So a rigid body when acted upon by a force can have two kind of motion. One is linear or translational motion, right? So in this chapter, right, is now basically we are going to talk about the force and motion as well, right? It's now so force creating motion, right? So when we are applying force on a rigid body, okay, so there are two kind of motion will be there. One is linear or translational motion, another will be rotational motion. So what do you mean by linear or translational motion? So here I can say this: if force is applied on a rigid body, okay, and the body start moving in straight path in the direction of motion. So here I can say this is the ball, okay. So if you will kick this ball, right, it's no means kick this ball means you will apply the force here, okay. So or you will push this ball, right, it's no. So here I can say that this is the direction of force. Now this will be the direction of motion. So direction of motion will be in the same path, right, it's no, that is in straight line only. So it will be known as translational motion here, right, yes, no. So it is called as translational motion. So in this type of motion, the entire body covers the same distance in same time, right? Yes, no? So if we'll kick the ball, so whole ball will move from one place to another place in a straight path, right? Yes, no? But that ball, if the ball is rotating, right? Yes, no? Means there will be rotational motion. Okay. So here I can say this: if a body is pivoted, right? Yes, no? If we'll see the wheel, cycle wheel, cart wheel, anything, right? Yes, no? So that wheel is pivoted at a point and a force is applied on the suitable point, it rotates the body about the axis, passing through the pivoted point. So the motion of the body is called rotatory motion. So when you are applying a force here, I can say that this is a pivoted point we have right here. So no, this is a wheel. Okay. When we are applying a force here, okay, this will start rotating like this. Okay. So now here I can see this point 1, right, is not touching the ground here, right? And next part when this wheel will move, okay, so then point 2 will touch the ground. So in rotatory motion, different parts of body cover different distance in same time. So here we can say different parts of body covers different distance in same time. Understood? So in this type of motion, entire body covers same distance in same time. That is what? That is translational motion. But rotational motion, in rotatory motion, if we'll see, different part of the body cover different distance in same time. Understood? So this is known as rotational motion. So there are two types of motion we have. One is linear motion, another will be translational. See, the next here we have movement or turning effect of force, that is known as torque. So how the symbol will be this, right? It's no. So here I can say this. If you'll know the Hindi, it is like 8, right? It's no. So it is tau. Okay. Factors. So factor affecting torque. Okay. So here I can say this first is force. So torque is directly proportional to force, or tau is directly proportional to force. Okay, so force increases, torque also increases. And second part, we can say perpendicular distance of force applied from the pivoted point. So here I can say this: if we are opening the door, okay, so why the door hinges are at the end point, right? Yes, no, or we can say edge of the door. So that perpendicular distance will be more. So perpendicular distance increases, tau is also increases. So collectively we can write torque equal to what? Force into perpendicular distance. So how we can define torque? So here I can say this: torque is defined as the product of force applied and the perpendicular distance of force, okay, applied from pivoted point. So torque is defined as the product of force applied and the perpendicular distance of force applied from pivoted point. So what is unit of torque? So torque is what? Force and perpendicular distance. So we can say SI unit of torque will be Newton meter, right? Yes, no, meter means here I can say this for distance, or in CGS we can write dyne centimeter. So if we'll see the relationship, 1 Newton equal to 10 to the power 5 dyne, right? And 1 meter equal to 100 centimeter. So if we'll write 1 Newton meter, so that will be how much? 10 to the power 7 dyne centimeter. Nature, okay, so torque is a vector quantity, right? Yes, no. So torque is a vector quantity, we can say. So we can see here types of movement. So there are two types of movement. We have clockwise movement and anti-clockwise movement, right? So if we'll see clockwise movement, right? So when force is applied to a body pivoted at a point, okay, so if the body moves in the direction of motion of hand of clock, it produces clockwise movement, right? Yes or no? So it is negative. Clockwise movement will be negative. It causes inward motion, right? Then here I can see this anti-clockwise. So it is positive here, right? Yes or no? And it causes outward motion. So when a force is applied to a body pivoted at a point, so if the body moves in anti-clockwise direction, so here I can say this, we are applying the force here, right? No, and that body moves in anti-clockwise direction, okay, with the pivoted point, then we can say it is anti-clockwise movement, right? Yes, no. So here the clockwise movement. So if we'll see this clockwise movement, so this is means like this, right? Yes, no. So this is going inward, right? Yes, no. So here it is going inward direction and anti-clockwise. So here I can say this, if we'll see, this will go outward direction, right? Yes or no? So there are two types. We have clockwise movement and anti-clockwise movement. Clockwise movement is negative and anti-clockwise movement is positive. Understood? So now the next part of this, right? So here I can say this, changing the direction of torque. So by changing the direction of force, we can change the direction of torque as well, right? Yes or no? So here I can say this first will be by changing the direction of force. So here, if we'll change the direction of force, so here we are applying force at this point, okay, from leftward direction. So this will move in clockwise direction, right? Yes, no, so it will create clockwise movement. And when we applied the force from rightward direction, right? Yes, no, then it is producing anti-clockwise movement. And here it is in the anti-clockwise direction. So force applied on same point. So if we'll see, the point is same only, right? Yes, no, but in different direction. So the direction of force is changed. So the direction of torque will also change. Okay, see, then next we have here one question, right? Yes or no? So here I can say this, why handle are fixed at free ends of the door, right? Yes or no? So why we are means we can say means free ends of the door, or we can say edge of the door. So here I can say this, why handle are fixed at free ends of the door, or we can say edge of the door. So it is because perpendicular distance, right? Yes, no, suppose you can consider this is a door, right? Yes, no, so this door is attached with the hinge here, right? Yes, no, and we are putting the thing here, right? Yes, no, that knob, or we can say that handles, right? Yes, no, we are putting at the edge of the door, right? So it is attached with the hinge here, right? Yes, no, so when we press at this point, right? Yes, no, it will be easier to open. So here I can say this, from the hinge, this edge distance is maximum, right? Yes, no. So if we'll put in the center, we required more force, right? Yes, no. If we'll put in the edge point, means in the side, right? Yes, no. In the means hinge point only, right? Yes, no. Door can't be open, right? Yes, no. So it is because perpendicular distance from the pivoted point of the door is maximum, right? Yes, no. So here, when torque is depend upon two things, one is force, another one is perpendicular distance. So perpendicular distance increases, torque will be increases. Okay, so we required less force then. So if we'll increase the distance, then we'll require less force. And if we'll decrease the distance, we required more force, right? Yes or no? So one thing should be in greater extent, either force, or we can say either distance. So here I can say this, why we are putting at the edge. So we can say it is because the perpendicular distance from the pivoted point, or we can say hinge of the door, is maximum at free end, or we can say edge of the door, hence torque is maximum. So that's why we are keeping the handles at edge of the door. Second thing, so if you'll see this in the village area, right? Yes or no? Why the upper circular stone of, means we can say means circular stone we have, right? Yes, no, of a hand, right? Yes, no, hand floor grinder has handle near rim again, right? Yes, no. So if you'll think like this is a circular part, and the handle in the rim, right? Yes, no, it is also in the corner, means edge point only, right? Yes, no. So again, from the pivoted point the distance will be maximum, right? Yes, no, that perpendicular distance will be maximum, so that we are putting that handle. Okay, so it easier for the means those they are in village area, they must know about this grinder, right? Yes, no, from this we are getting the, we means we can say that flours, wheat flours and all, right? Yes, no, and someone also masalas and all, right? Yes, no, they are getting from there only, right? So due to maximum perpendicular distance from pivoted point, the torque is maximum, right? So this will be there. That's why we are putting at the edge, or we can say end point, or we can say means near the rim, right? Just no, near the rim also. Understood? Again, we have here next part, turning of toothed wheel of bicycle, right? So these are the means what applications of torque we can say. So in a bicycle, to turn the wheel anti-clockwise, right? Yes, no, to turn the wheel anti-clockwise. So here we are paddling this, means here you can see this, a small force is applied on the foot paddle of toothed wheel size bigger than the rear wheel. So here I can say that this size is smaller, this size is bigger here, right? Yes, no. So we are applying force on this paddle, right? It's no foot paddle. Okay. So the perpendicular distance of the point. So here I can say that this is axle we have. So from here to here, this perpendicular distance is maximum, right? Yes, no. So point of application from the axle of wheel is large, and we'll feel means that torque will be large. So we require less force. Then spanner or wrench used to tighten or loosen a nut. Again, you can see this here. You can see this nut point, right? Yes, no. We are applying the force here only, right? Yes, no. So this handle means we are taking in the distance, right? Yes, no. So this is perpendicular distance, right? So here it creates the rotation. So spanner or wrench applies torque to tighten or loosen a nut, okay, with torque being the rotational force equal to the product of force and distance from the pivot, right? Yes, no. So spanner or wrench used to loosen a nut, right? Yes, no. So here you can see this distance will be maximum, so torque will be maximum, force will be less. Okay, so that we can say means that's why we are keeping that handle means in the distance. The next thing here, when two forces act on a body pivoted at a point, right? So here I can say this, when two forces means here two parallel forces we can say in the same direction, right? Yes, no, when two forces means we can say here it is parallel forces and they are in same direction, right? So here I can say this, we are applying the force at point A, another force we are applying at point B. Okay, both are separated by a distance we can say S here, right? It's no from O. Okay, so if we'll write the formula for torque A, right? It's no, so it will create here, I can say this anti-clockwise, right? It's no, so anti-clockwise, that is positive, so torque A equal to what? Force into perpendicular distance, so F into S, so it is anti-clockwise direction. Similarly, if we'll write here for B, so torque B equal to minus F into S, right? Yes, no, this will be in clockwise direction. So here I can see this is creating clockwise movement, right? Yes, no, so clockwise direction. Adding torque A and torque B, right? Yes, no, so we'll get what? Total torque. So total torque equal to how much? Torque A equal to torque B. So torque A equal to torque B equal to Fs plus minus Fs. So Fs minus Fs equal to what? 0. So now what will be the conclusion here? Parallel forces applied in same direction and different point of application produces zero torque. So different point, but here I can say this same distance, right? It's no means we can say here different point. So same distance from pivot point, right? It's no same distance from pivot point, right? It's no in the same body. So here I can say that this will be the center. Okay, if we'll add both, so here it is center we have, there are two parallel forces, one is creating means one is giving clockwise movement, another one is giving anti-clockwise movement, so both will cancel each other, so total torque becomes how much? 0, right? So total torque equal to 0. See, next thing we have couple. So two equal opposite parallel forces not acting along the same line from means it forms couple, right? Yes, no, they are parallel but they having different point of application means They are in different direction. So torque A means here I can say this torque A equal to what we will write here, F into OA, and torque B equal to F into OB. So here I can say this will create anti-clockwise. Here also this will create anti-clockwise direction. So both are creating what? Anti-clockwise movement. So total torque equal to torque A plus torque B. So F into OA plus F into OB. So now we will take F as common here. So OA plus OB is equal to how much? AB, right? Yes, no. So OA plus OB is, so F into OA plus OB is F into AB. So F into AB is total distance between the two forces, right? Yes, no. So that is F into D, right? So we can say F into D. So moment of couple is the product of either forces. We are taking either forces into distance between them, right? Yes, no, so force into distance between the two forces, we can say, right? So that is moment of couple. So next topic here we have equilibrium of bodies. So equilibrium when a number of forces acting on a body, okay, produces no change in state of rest or motion. Whether the body is in state of rest, that body is going to in that same state, okay, or whether the body is in state of motion, that is in the motion only. So there is no change in the state of rest or state of motion of the body is said to be in state of equilibrium. In other words, when number of forces act on a body such that the body is able to maintain its original state is said to be in equilibrium, okay. Means when we are applying number of forces on a body, okay, such that the body is able to maintain a state, right? Yes, no, original state is said to be in equilibrium, right? Yes, no. So means that if the body is in state of rest, that body is in the same state or after applying the force, or if we are applying force to stop some body, right? Yes, no, that is in motion, okay, but the body continues that state of motion, we can say that body is in equilibrium. So equilibrium is of two types. One is static equilibrium, okay. So as we discussed that rest and motion, there are two parts. So static equilibrium when number of forces act on a body, okay, which is in state of rest. So here I can say this body is in state of rest and we are applying number of forces here F1, F2 and W, right? Yes, no. So when number of forces act on a body, okay, is in state of rest such that the body continues to be in the same state, it is said to be in static equilibrium. Example, a book kept on a table. And we can say here, right, is no a physical balance here, a physical balance in a balanced position, right? Yes, no. Then we have next here it is dynamic equilibrium. So when number of forces act on a body which is in state of motion such that the body continues to be in the same state, it is said to be in dynamic motion. Example, a fan, raindrops falling on ground. These are the examples. So the speed should be remain same for dynamic equilibrium. If a body shows increase or decrease in speed during motion, it is not in dynamic equilibrium, right? So the speed should be remain same for dynamic equilibrium if a body shows increase or decrease in speed. So if the speed it changes, right? Yes, no. So we can say there is no equilibrium, or during the motion, right? Yes, no. If it speed is means sometime the speed is means 60, sometimes it is 30, right? Yes, no, it should be in kilometer per hour or meter per second, okay. So speed during the motion is not in dynamic equilibrium, we can say. So if it is changes, condition of equilibrium, the resultant of all forces acting on the body should be zero. So summation of F equal to what? Zero. So here I can say this F1, F2 will cancel each other, and W will cancel each other. So we can say this body is in equilibrium, right? So here F1 equal to F2 in magnitude, and we can say F2 equal to what? Minus F1, since it is opposite direction. Similarly, we can say that normal and weight, okay, both are opposite in direction. So N equal to what? minus W here. So summation of F equal to what? F1 plus F2, okay, plus W plus N, means total force should be added. So F1 and F2, right? Yes, no, both are means opposite in direction. So in place of F2 we can write minus F1. In place of N we can write minus W. So here you can see this F1 plus F2 plus W plus N. So F1 minus F1 plus W minus W. So it will be 0 minus, or 0 plus 0, it will be 0 only. Or second thing, the algebraic sum of moment of force about an axis of rotation should be 0. So means summation of, means here I can say this, the total torque will be what? 0. So torque, that is anti-clockwise, A, plus torque in clockwise equal to how much? 0. So here I can say this, it is producing, here it is, this should be what? Anti-clockwise, and here it is producing clockwise. So the algebraic sum of moment of force about an axis of rotation should be 0. So what will be principle of moment? At equilibrium, sum of clockwise movement is equal to sum of anti-clockwise movement. Reason, we know that total torque means summation of total torque equal to what? 0. So summation of torque A plus summation of torque C, means here it is torque means what? That is tau A means clockwise, and tau C means here it is, sorry, so tau A means anti-clockwise and tau C is clockwise. So both are, means we can say that is total torque, right? Yes, no, so tau C means here it is what? That is minus only. So summation of tau A equal to summation of tau C, means including directions, right? So here it is including direction, means that should be negative. So summation of tau A equal to summation of tau C. So here it is given, right? W1, W2, and both are, means this is, we can say, the pivot point we have separated by a distance d1 and d2. So here I can see this is tau clockwise, right? Yes, no, that is W1 into d1, and tau anti-clockwise, that is W2 into d2. So then W1 into d1 equal to what? W2 into d2. Now here we can see this numerical we have, okay, that is, a body is pivoted at a point, okay, a force of 10 newton is applied at a distance of 30 centimeter from the pivot. So calculate the force about the pivot. See, so here you can see this, a body is pivot at a point, right? A force of 10 newton is applied. So what are things are given here? You can say this, okay. So if we'll see here, okay, that is force is given. Force equal to how much? 10 Newton. And the perpendicular distance is also given. Means if the body is pivoted like this, right? Yes or no? And we are applying the force here, okay, and this pivoted point distance from here to here, it is 30 centimeter. Okay, so calculate the moment of force about the pivot. Okay, so what we need to calculate here? Moment of force about the pivot. So first thing here we'll write, okay, the given thing, right? Yes or no? So here given force equal to how much? 10 Newton, okay, and the perpendicular distance, right, equal to how much? 30 centimeter. Okay, so since here I can say this, if we'll see here, right? Yes, no, that is, that distance is given in centimeter, so we need to convert this distance into meter, right? Yes, no, so what we'll write here? So how to convert the centimeter into meter, that you know, so we'll write here 0.3 meter. So what will be the formula of moment of force? So moment of force equal to force into perpendicular distance, right? So here I can say this is a body, consider, okay. So here we are applying the force equal to 10 Newton, okay. So now this body changes, right? Yes, no. So 10 Newton into 0.3 meter equal to how much? So here 10 into 0.3 equal to 3. So here we have 3 Newton meter, right? Yes, no. So we have the formula for torque. Torque equal to what? Force into distance. So force into distance means here I can see this. This will be force is given, that is 10 Newton meter, and that distance, okay, means that, sorry, force is given 10 Newton and the distance is given 30 centimeter. So centimeter need to convert into meter. So here it is 0.3 meter. Okay, so now we'll apply the formula, and 10 into 0.3, so it should be 3 Newton meter, right? So this will be your answer. See, the second question is given the moment of force of 5 Newton about a point P is 2 Newton meter. Calculate the distance of point of application of the force from the point P. Okay, so here we can write first thing what are things are given we have, right? Yes, no. So here I can say this force is given, that is 5 Newton. Okay, and another thing we have, that is torque, right? Yes, no. So tau is given with respect to the point P here, right? Yes, no. That is how much? 2 Newton meter. So we know that formula, right? Yes, no. That is torque equal to force into distance, or perpendicular distance we can say. So force into distance. So if we need to calculate the distance here, okay, so distance equal to torque upon force. So here we can write this torque value is given 2. Okay, so here I can say this 2 Newton meter I am writing, and the force value is given 5 Newton. So Newton will be cancelled, 2 upon 5. So this should be 0.4 meter. Answer. So this will be the answer for second question we have. Then third question, here I can say this. A mechanic can open a nut by applying a force of 150 Newton while using a lever handle of length 40 centimeter. So how long handle is required if we want to open it by applying a force on, means here it is only 50 Newton. Okay, so how much, means what will be the distance, right, yes, no, of the handle? See, so a mechanic can open a nut by applying a force of 150 Newton. So if we'll write here, right, yes, no, that is first case. Okay, so in the first case it is given, right, yes, no, that is force equal to 150 Newton and the distance is 40 centimeter, right, yes, no. So force equal to, here I can say this, 150 Newton and distance equal to 40 centimeter. So I'm converting this into meter. So this should be 0.4 meter here. Now the moment of force needed to open the nut. So the moment of force needed to open the nut means basically it is talking about the torque. Okay, so force into distance. So 150 into 0.4, right? So 150 into 0.4 equal to how much? So 150 into 0.4 will be equal to 60 Newton meter. So here I can see this. This was the first case. We have 60 Newton meter we are getting. Then if we'll see the second case, okay. So if we'll see the second case here, in the second case, force is given 50 Newton. So let the handle of, means here it is the length of the handle equal to how much? L. So let the handle length is L meter, right? Yes, no. So moment of force equal to what here? Force into length, right? So force into length, so 50 into L, and we got the value moment of force, right? Yes, no, in the first here, right? Yes, no. So moment of force in the first equation, if we'll see, that is 60 Newton. So here I can say this, okay, from equation 1 we will take that is 60 Newton meter, that is moment of force, okay. So 60 equal to 50 into L. So if we need to calculate here L value, right? Yes, no. So L equal to what? 60 upon. So L value is 60 upon 50 here. Okay, so 60 upon 50 equal to how much? So this will be equal to 1.2 meter, right? Yes, no. So here we'll write 1.2 meter. So that length should be, means here I can say this, okay. So a mechanic can open a nut by applying a force of 150 Newton while using the lever handle of length 40 centimeter, right? Yes, no. So how long handle is required if we want to open it by applying a force of only 50 Newton, right? So here I can say this, the handle length should be 1.2 meter, or we can say 120 centimeter. Understood? So next question we have iron door, right? Yes, no, of a building is 3 meter broad. Okay, so that iron door is 3 meter broad. Okay, it can be opened by applying a force of 100 Newton normally at the middle of the door. So calculate the first thing here, the torque needed to open the door, and the second thing we have the least force and its point of application to open the door, right? So what we will do in this? So here I can say this. Okay, it is given, right? It's no force equal to 100 Newton. So here total distance, right? It's no the iron door of a building is 3 meter broad. Okay, so total width is equal to how much? 3 meter, right? It's no. So this is the door, you can say. Okay, so here I can say that this is 3 meter broad. Okay, then force equal to given here 100 Newton. Okay, so now it can be opened by applying a force of 100 Newton normally at the middle of the door. So calculate, means middle, when it is applying at the middle, right? Yes, no. So calculate the torque needed to open the door. So if we are applying middle at the door, means R will be equal to how much? That is 1 by 2 and 2 breadth of the door. So it is 1 by 2 into 3, that is 1.5 meter. So torque equal to 100 into 1.5 equal to 150 Newton meter. So this will be answer for first question here, right? Yes, no, that is A here. Then second part, the least force and its point of application to open the door. So here we can say this, the torque is 150 Newton, so we'll write it, okay. Then F dash we need to calculate, and D is 3 meter here given. So F dash 150 upon 3, so 50 Newton force is required to open the door. Understood? So if we'll see, today we'll learn about the thing that is force, turning effect, right? Is no, that is moment of force, we can say torque, right? And then that is circular motion, right? Yes, no, that means we can say that is rotational motion or linear motion we have, right? So means we solved some numerical as well. Okay, so if you found this video helpful, don't forget to hit like button, okay, share it with your friend, and subscribe to Success Spectrum Academy for more such educational video. Also your drop, means we can say, also you can drop your doubts, okay, or suggestion in the comment section, okay, below, and I will happy to help you, okay. And one more thing, this is the part 1 of force, okay, that next part will be coming soon, okay. So don't forget to hit the subscribe button. Okay, or you can like this videos as well. Okay, thank you so much for watching this. Okay, please do subscribe. Thank you.